Hi everyone, so thanks for joining the talk. So today my talk is about improving the stability for running Python SDK. And when I say Flink runner, it's mostly portable Flink runner. And my name is Lydian, and some background for myself. I'm currently a staff engineer at a firm and the infra streaming teams. My journey for background, I was originally mostly on ML engineer and then switched my focus to ML infra. And then I figure out that streaming is probably the most important things in the future, because for machine learning, it doesn't make sense if you are not predicting with more up-to-date values. So I start focusing on streaming and switching to the team, the streaming infra teams. And for my personal life, I'm a cat lover. I'm not sure how many of you loves cats. And if you want to connect me, there are my LinkedIn, and there are some cat-related projects in my GitHub repository if you are interested. And then let's move to Affirm. So hopefully you already know what Affirm is. It's a buy now, pay later company. And some numbers of us. First thing is we are currently having about 18.6 million active users, active consumers. And compared to last year, it's about 14% growth. And there's 93% of the transactions are actually from repeated users. And for the quarterly transactions, we are currently 24.7 million. And compared to last year, it's 42% growth. And next, for the merchants, we currently have 330,000 active merchants. And compared to last year, it's 19% growth. And if you are looking for like the larger gross market values merchants, it's actually about 20% growth. So that's the data that we're handling day to day. And so today's agenda, I would want to first share with you what's our original setup and our stability issue that we are actually facing, and what are the things that we discovered, and finally, what are the updated architecture that we do for solving the problem. And there's also some other improvement that we found is helpful, and finally, some summaries. So let's first talk about the firm's original Beam Flink runner setups. So we start doing the streaming processing around 2022 or 2021. By the time when we start this project, there are no existing. We decided that we want to use Flink because we compare a lot of other streaming solutions, open source streaming solutions. And the Flink one is the best compared to like Spark. It has the best performance. And then we are looking into the Kubernetes operators for easier to deploying our projects. And by the time when we start looking this one, I think there's only one Lyft Flink operator is available. And that Lyft one is also only the one that's being used widely as in production use. So we decide, hey, it sounds like it's a nice choice, so we should go with that one. So we start with the Lyft operators. And then also in the same time, it's worth to mention that because the Lyft operator doesn't directly support PyFlink. So that's the reason why we start looking into Beam, because Python is a big thing for our companies. All of our ML team, they are really like to use Python and doesn't want to use Java. So we have to support Python anyway, and Beam is definitely the Python SDK is definitely the way to go for us. So we have to support Python, we have to Flink, and we want to run everything in Kubernetes. And so the way that we achieve that is by running this Beam app with the environment type code process so that we can run it in Kubernetes. That's the basic settings that we have. And if you're interested, there's actually a talk last year for the similar, what we do. But more high-level things, it looks like this is the graph that we're, the settings that we have. So in the beginning, you have the Flink runners that will launch the Flink cluster for you. Cluster means the job manager and the task manager. And then once the cluster is launched, the runner will keep up the Beam runner jobs, and the Beam runner job will spin up like artifacts, expansion service, and job service, of course. And then that will translate everything to the Flink job manager, and the Flink job manager will come dispatching the job to the task managers. And inside the task manager, you depends on what you are working. So for example, we are using Kafka IO, which is a Java library. So it will run on the Java process. And But for other transformation that we have is mostly Python one. So it will spin up another Python harness SDK, another Python harness process. And the Python harness process will run for our Python stuff. So that's our existing settings. And we use this setting seems to be working fine in the beginnings. So we kind of gradually expand our usage. And right now we have around like 1,000 Flink apps running with the same settings. However, when we grow the number up, we found that there are some limitations. First thing is the Lyft operators. When deploying, we found that it's unable to successfully update its state. And so, which means that every time when we are deploying, there are roughly about at least 200 Flink apps that we need to update. But every time the Lyft operator is only able to successfully deploy for around 30. So it's like a very prolonged process. You have to keep retrying and until it finishes on all the things. And it takes probably like 2 to 3 hours. It's definitely not manageable for a regular, if you want to deploy more regularly. And also there's another issue with the high availability. It seems like it's only support some lower version of high availability on Flink. So we have to patch that by ourselves to support the more up-to-date version of Flink for high availability. And what is also worth to mention that it looks like the Lyft itself is not also actively maintained on these operators. So we are migrating out of this Flink their Lyft operator. And we think it's a good time that we should move out of this outdated operator. And luckily, by the time the Apache Flink operator, which we call it official operators, and it's available and it's also widely being used by many companies. So I think it's a good time that we start looking into that one. And initially, when we are doing this migration, we think it's a very easy migration because nothing really changed. You just change from one CRD to the other CRD. That's simple, right? But turns out it's not. So we found that after we are doing this migration, we see a lot more out-of-memory issues. And these are the common errors that we are seeing from our job manager logs. So sometimes we do see the SDK harness connection loss, and sometimes we see the test manager loss. So many different issues, but they all point to the same thing, that it looks like the test manager is OOM. And so because nothing is actually changed, the only change is the operator itself. And so we are looking into more deeply on how the difference between the Lyft operator and the Flink operators. And actually we found something interesting. So in the Lyft operators, it has a default setting called system memory fractions. And by default it's 20%. So which means that if I assign for 4 gigabytes of the memory, it's actually only assigned 3.2 gigabytes of memory to the job resource, to the Java process. And the other 0.8 gigabytes will be reserved for like some ecosystem. But when we are discovering, it's actually used by Python as well. And for the Apache Flink operator, it's doing a different things. So when you say, I want to give it a 4 gigabytes, it will dedicate almost all 4 gigabytes to the Java process, which means that the Python doesn't have anything. So the way that we are trying to resolve this problem is if you look at our current systems, we have the Python process and the Flink and the Java, they are all in the same containers. And that's where the issue comes in, because for the Python one, you definitely need to schedule more resource for itself. And so, right now it looks like with the Flink operator, you cannot do that. And the solution that we come up with is we now separate the harness SDK to its own container, like a sidecar containers. And to do that, you can now have your own configuration for your Python worker harness. And that does solve the problem for us. And take a more deeper look on the code. So the way we start our harness container is by providing the startup arguments with the -- worker pools. So that will start the harness process for us. And in the same time, when you are publishing your Beam apps, you want to set the runner's environment type to be external and the environment config to be the localhost 50,000, which is the default port from the harness process. And with that, we actually seeing a huge improvement for our OOM issues. And some other side benefit besides for this issue being resolved, by doing that is like, because now the the Python harness is now its own container. So we have the freedom to set what's the request and the limits for itself. And the other thing is like, because it's a separate container and the Kubernetes actually have some good monitoring tools to tell us what exactly the memory usage, the CPU throttling. So all out of box. So we don't need to do some extra investment to see how to do the profiling for those Python process. So I think that's some benefit that we get from these investigations for how to make things better. And besides for that, there are some other improvement that we did. The first one is mostly Flink ends. In Flink, you can set up your checkpoint if you want to use Presto or Hadoop. And Presto is definitely faster than Hadoop. And from our experiments, there's one pipeline has a checkpoint time around like 5 minutes. But by switching to the Hadoop, it's actually lower to like 2 minutes, which is more than 50% improvements. And the other thing we do for the task manager is to put them all runs in the same AZ. We're in the AWS cloud, so we just put them to run all in the same AZ, and that will minimize the network communication. And from our look, it does seems like the task manager is much more stable. And also we have a dedicated node pool for those K8s, but for our Flink job to better control those resources. And this is not the stability, but it's kind of worth to mention. We also changed the instance types. So initially we are using a generic instance types, but we switched that to a memory efficiency one. And that does save us cost for about almost one and third for the entire cost. So that's the things that we think that's good to mention for our journey in the past for how we stabilize our stuff. So in summaries, the Beam Python SDK doesn't seem like it's something, if you are familiar with PySpark or PyFlink, it's not something similar to those, because for those things, the Python library is just a thin wrappers. So when you are running the functions, it actually still using the Java's memories. But if you are running a Python SDK, you definitely need to consider allocating a huge amount of memory for itself. And the other thing is, thanks to the Flink operator using the pod template, you can actually easy to spin up another sidecar container for your Beam SDK harness process. So that does save us. And so if you want to get your hands dirty, I do have some examples that I have on my GitHub repository. And there are some Docker Compose example and Kubernetes examples, Kubernetes.yaml files. So you can take a look on how we build up those things. And finally, thank you.